All right, guys, so today, like the title says, I'm going to be taking some baby steps into milling in Fusion 360. Um, Full disclosure, uh, this isn't my first rodeo. I've been, machining for 25 years. I've used all sorts of different software platforms and seats and whatever, what have you. Um, but that being said, they all have their little, different ways they do things, and Fusion's no exception to that. Um, but I have been using Fusion a little bit for lathe work. I've done a few jobs on the lathe in Fusion, so I'm getting my head wrapped around it a little bit, but I haven't really done any milling yet. So we're gonna dive into milling today, mainly because I have this project that I do for Kaizen Speed. All we do is open up this bore and put this inside chamfer back on these rotors here. So super simple job. However, I'd like to try to figure out how to automate it a little more. And typically we pick up the bore of these with the probe on every single part so that they're always perfect. They're always, concentric to the bore that was already there. So I'd like to automate that probing if I can. I know that's a function in Fusion that you can use. So I'm going to see if I can figure that out today, and you guys can struggle through it with me. So I've done these parts many times in the past. I already have a program. I already have jaws cut for it. But, it's such a simple thing. So these are the jaws I have cut. It's such a simple part that I'd really like to, use it as a learning platform for me to start getting into Fusion a little heavier. I am attempting to basically change over all of our programming and modeling into Fusion instead of the old software I've been using, mainly because of cost. So some of those other softwares are very, very expensive, and Fusion, for the base seat is only like $500 a year. So that's kind of a no-brainer as we go forward here. And you still get, 95% of the functionality. Some of it's not quite as refined, I would say. But for the price, you're getting 95% the functionality for a 20th of the price. Plus, you have milling right in the software package. So that's or machining, I should say. So that's a huge benefit. So that's why we're kind of getting into this. All right, so getting into Fusion here. Okay, so we have a new untitled drawing here. So we are in design, so we can start with designing the model. This is going to be a really, really simple model. We basically just need a hole and a chamfer. So none of the outside, profile of that rotor matter. Only that bore matters. So, okay, so we're going to start our sketch on the top plane here. Well, I don't know what they call that actually, but so we have X in the left to right direction, Y in the, I guess, forward and aft direction, and Z is straight up positive towards our view here. So we just need to create our model here. So I just picked the circle. We're going to give it a dimension of 68.2 millimeter. So that's the bore dimension that Kaizen Speed wants these to be at after we machine them. And we're just going to give this another circle out here representing the rotor face. We can just give that an arbitrary dimension because it doesn't matter. So we'll just say 5 inches. And then we're going to hit the E button for extrude. Alternatively, you could go up to here to solids and hit this extrude button, but E works good. We'll select basically the closed contour that we want, and then we'll give this a dimension. I'm going to go measure that rotor and see how thick it actually is. So the rotor face is about 218 thick. Oops. Let's go back to that. 0.218. Enter. So now we have our thickness, and now we need to add our chamfer on here. I'm going to measure that chamfer as well and see how big I believe that chamfer to be. So we have about 80 thou left of this thickness. Once the chamfer is there, there's about 80 thou left of the flat. So we're going to go up here to our chamfer tool, and that puts we'll select this edge. That puts our chamfer at 0.2. Let's see if it'll do the math in here. Minus 0.08. Yep, so it does the math automatically for us. If we go edit this feature, I guess it doesn't actually tell us the math, but it does it for us. So I guess that's what, 138 thou or something left. So this chamfer is about 138 thou. So that should be all we really need as far as the model goes, because we're just going to be milling out this inner diameter and then putting the chamfer back on there. So that should be all we need. So let's switch over to manufacture here, and we'll get started. So the first thing we have to do is do our setup here. So we're gonna edit this, or make a new setup, I should say. So this is basically the material that you're going to be machining away. So it's your stock material. In our case, we have basically a really thin or a really short length tube. So let's see what we can do here. Let's go, that's our work coordinates. Looks correct. Origin looks correct. Let's go to stock. So we're going to do a fixed size tube, probably. So stock diameter, 5 inches should be fine. So that's the outer diameter. Inner diameter is what we're going to need to change here. So our rotor, I'll measure it right now, currently has a 2.532 inner diameter. So we're just going to put that number in here, 2.532, and then our length is going to be the same as what we measured our rotor to be, which was 218. So now we have our stock. So this is all we have to cut away just to change that bore diameter. I'm going to go, I haven't used milling yet, so let's see if we can go select the right machine here. We're just working on a VF2 SS. Looks like we have VF3 SS. It's got to be in here. It's their literally most popular machine, but maybe not. Let me go see if I can find it on their site. So it looks like they don't seem to care about the SS feature on the machines. So I suppose we'll just use, let's see. They do have an SS VF3, which is strange. But we'll just use the standard VF2, and we'll select that for now. I'm not going to bother with modeling the actual machine layout right now. So I guess in reality, this is just this must just be like the 3D rendering of the machine, and then in our actual post processor we should be able to pick, I would imagine, pick the SS model of the VF2. So we're just going to cancel this. Let me look through these. So we have milling, our work coordinate system looks to be correct. Stock point, blah, 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 stock. And then post process, our output for our number. We'll put work coordinate system 1, which will be a G54 work coordinate system. So we'll say OK there. So now our setup should be pretty much done and ready. So then we can go into milling here. It automatically populated this. But actually, I want to try to figure out probing. So it's probably an inspection, probe work coordinate system. That sounds like what we want to do. Let me play with this a little bit, and then I'll show you what I've figured out. All right, so here's how I think this is going to work. We're going to go to inspection, probe work coordinate system. We're going to select a tool. In the tool library here, there's probes under the Fusion library. And then I just click down to figure out, this one looks like mine. So that's the one I'm going to select. They're all 6mm ball, which is what I have, and I'm sure you can edit this tool and change that if you have a different stylus. But we're going to select that. It automatically populates some feed rates here, and they look to be relatively normal for probing. So I'm just going to leave those the way they are. And now we get to figure out our geometry that we want to probe. So we're going to probe, let's probe stock. And then, so now it's showing us the stock, and we need to select the surface we want to probe. So we're going to select this inner diameter. That looks like it's correct. XY circular hole. Approach distance, over travel distance, where it'll alarm out if it over travels. Position tolerance seems to be okay. So now we got to do our heights. So this is our clearance height, which is probably good considering that's up and outside of the realm of the rotor itself, since the rotor kind of comes up. Sorry, my mouse is funky. Rotor comes up and out, so this will be plenty of clearance for that. And then we have like a feed rate clearance, which is our retract height. So that's our stock top plus 0.2. That seems, just fine. And then we have our bottom height, which is basically where it's going to probe. So let's do stock bottom plus our flat that was in there was 80 thou, so we'll go plus 0.04. So that puts this probing depth basically right in the middle of our flat that's already there on the rotors. So we'll hit, let's go over here. Work coordinate system. So work coordinate system to be updated is 1. What is this? Okay, so this basically says that we need to use a single work coordinate system, or we can have like a home position and then have it update to a different work coordinate. So I think what I'll do, I think just leaving that the way it is correct. We'll see. I might have to play with that later. But let's just click OK. And then everything calculated correctly. So let's simulate this. So it comes down, looks to be probing at the right depth. So it probes our bore, sets our work coordinate system position, and we should be good there. We'll see when we go to actually, run it, what happens, but it looks correct to me. So previously, I would have to basically manually jog this down, touch off on every single part to make sure it was right, and then run the program. So in this one, I think that we're going to just have to touch off the first one, and then from that point on, it's going to probe that bore at the beginning of the program and automatically set the work coordinate system to be the center of that bore, which is kind of automating the process a bit and seems like it'll be much better to me. Remember, our focus from a previous video going forward into the future of LPS Fab is automation. So any efficiencies I can add during the programming of parts and, you know, fixturing and things like that are always going to be a plus. You know, something like this part, maybe we could have done 3 at a time in the machine or something like that. But they typically only send me about 10 of these at a time, so there's no real point in getting crazy with the setup and cutting jaws and all that kind of thing. But I think this probing is going to enhance efficiency pretty good. So let's keep going here. So we're going to click over to milling, and we need to basically rough this out with a end mill, probably just a 1/2 inch standard steel cutting end mill that we typically use. So we're going to be in a 2D toolpath here. We've got adaptive clearing. Let's see what our options are here. 2D adaptive clearing, so that's kind of like a high-speed machining style toolpath. 2D pocket, face, 2D contour, so that's outside profile, looks like. I guess it could be inside profile depending on the geometry. Got a circle mill here. So not a whole lot of options in the base Fusion 360 package, but it looks like there's plenty of options to do what we're trying to do. So I prefer adaptive clearing. Let's see if we can make that work. Okay, so we're gonna pick this adaptive clearing. This pulls up our little manager here. We're gonna turn coolant off. Just because this is cast iron, it doesn't really need coolant. We're only taking a little bit off, and we're going to have some fairly slow feed rates. We need to select our tool. I've gone and made a extra tool library here for my VF2 tools. I copied the probe and put it in this folder, and then I copied another tool that I had used in the lathe, which is this 1/2 inch end mill. I just put that in this folder as well so that I can select that, since I knew it was already kind of set up. So this is a 1/2 inch bullnose end mill. It's got a 15 thou corner radius, 1.25 inch flute length, 3 inch overall. It's running at looks like cutting feed rate is 18 inches a minute at 2292 RPMs or 300 service feet per minute. So that should be fine for what we're doing. So I'm going to select that tool. And then we'll just basically go through this little manager one thing at a time. So we're going to have to select our contour. So we need to select this inner contour. So I'm just going to pick chain. I'm going to select this bottom chain here, and then make sure the arrow is going the direction I want to be climb milling. So that looks correct. That means the cutter will be spinning this way and climbing up the part basically. So that looks correct. We'll say okay. We don't need any of this other stuff, it looks like. So now we got to go to heights. So we have a clearance height, a stock top height for our retract, an actual stock top height, so that's got a 0 offset in it. The retract has a 0.2. And then our bottom height is selected contour, so we can select from all these different ones, but selected contour seems good to me since we picked that bottom contour. However, our end mill has a bullnose on it, so we want to go past that a little bit. So I'm going to go minus 0.030 on that to make sure it cleans up that bottom edge without leaving a little sharp radiused thing at the bottom there. Now we'll go to our passes. It looks like optimal load, it seems like, is our kind of our step over, I guess, if you will. So we're not taking a ton here. We're going fairly slow. It's cast iron, cuts easily. So we're going to leave that at 0.2. If I was cutting a harder material, I'd probably turn that down a bit. But I think that we'll be okay there. Climb milling is correct. Stock to leave, so we're leaving 20 thou for a finish pass. That sounds good to me. A lot of this stuff is kind of already populated with like relatively rational data, I guess. So we're not ramping, we're not doing any of this. So let's just say okay and see what happens. Okay, so we get a kind of a rapid down into the hole, it looks like. We get a feed in, and we get a nice contour. This is center line of the tool, that's why it's offset from the surface. And then it ramps out, it looks like. So let's simulate that. So I'm just right clicking on this, clicking simulate, and then hit play. So, yep, that looks like exactly what we need. So we'll exit that simulation. That looks perfect. So now we need to do a finish pass. So let's see, probably 2D contour would be our finish pass. So same thing, go through the menu, populate it, see what you can figure out. So we'll select the same tool from our VF2 library, select, turn the coolant off, disabled. Geometry is going to be our bottom chain. Okay, heights. Again, we'll add this negative 0.03 in here. That should be good. That should be our finish pass. Okay, so this chamfer I've had to mess with a little bit. It seems the chamfer function in Fusion doesn't have like a multi-passes feature. So what I've had to do is I changed the height here for our selected contour, which is our face, the face of the chamfer. Here, I'll just go through this. Here, so our chamfer face was our contours. After selecting that chamfer tool, my tool is a 1/2 inch 90-degree chamfer with a 30th flat on the bottom. Had to kind of modify that in the tool manager. But on our heights here, this is a pretty big chamfer to take in one pass. So I basically offset our selected contour by a couple passes here. So this one has a 50 thou offset. This next one, so all I did was take this and I hit duplicate, and it added another one here, and then I changed the offset in this one. So this one's 20, and then this one is 0. So basically what it does is it makes 3 different height passes on that chamfer. So basically like 2 roughing passes and a finish pass. Because the tool, the operation, I guess, the chamfer operation doesn't give you that option, at least as far as I could figure out. But I think we're pretty close here. I think we've got everything we need. So I'm going to figure out the post processor and get this onto a USB and over to the mill, and we'll see what we can figure out. Okay, so I've got the program loaded. I cannot watch it in graphics mode because the probe fails. So that's kind of sucky, but we'll just go slow through this and see what we get. So first thing I need to do is I need to call up the probe. Oops. Cancel, delete. So we need to touch off this first part manually so that it knows where G54 is, so that it can probe the next one, if I understand it correctly. So I'm going to go ahead and do that. Now I need to load up my tools and get them touched off. So we're on tool number 1 and tool 2. And now we're going to touch off those tools. now that that's all done, we're ready to run our program. Okay guys, so I've never done probing via cam before. So we're going to take this really slowly and just work through this program in a safe manner. So I've got my rapids down, I've got my optional stop turned on, and let's just see what happens here. I'm going to go to my distance to go page. So I have 1.4 inches to go in Z. So that looks correct. It looks to be centered in the part. So looking good so far. Probe turned on. Yeah. That seemed like it functioned perfectly, so that's awesome. Automation. Alright, so now we're going to go to our first machining tool. This is our tool number 1, 1/2 inch end mill. Well, that wasn't supposed to be on. Let's see what happened there. Okay, so I did miss a coolant on one of those tools. So that was a little surprising, but I think I got that fixed now. Got the program re-uploaded, so let's try again. Uh-oh, we got a tool arm failure. Okay, so still working out a few bugs from the move. Apparently my air pressure was set a little bit too low on the machine and the tool change failed. So, starting again. Well, we know the probe works, so let's just go to tool 1 in the program here. We'll start there. So far, so good. Although when that coolant came on, I heard some funny coolant trickles back here. And it looks like I've got a hose failure somewhere up in there, which sucks. I guess something else happened in the move. All right, let's run the last tool here and see what it did. I have a little air blast hooked up to this little valve here. Helps when you're cutting dry like this. Blows the chips away so you don't recut them. Pass. I could probably change that ramp in a little bit. Sounds like it kind of comes in a little hard right at the start. Camper looks to be perfect though. So, there you go. All done. So, success, I would say, for our first try milling in Fusion 360. Thanks for watching.